Relative motion is all about the motion relative to a specific perspective, reference point, or sometimes we will consider a frame of reference. Okay, so we have three objects. We have a helicopter, a car, and a tree. Okay, the speedometer of the car reads 50 kilometers per hour. The speedometer of the helicopter reads 50 kilometers per hour. Then we're going to calculate the relative velocities providing the direction. So, if the tree is the reference point, if you are standing next to the tree, what is the velocity of the car? Well, remember, velocity is both speed and direction. The speed of the car relative to that tree is 50 kilometers per hour. Direction, north. Okay? Velocity of the helicopter relative to the tree is also 50 kilometers per hour. Also going north. That's easy, and you're probably thinking, well, what's the big deal? It gets a little more complicated. Imagine you are in the car. The car is the reference point you are driving. Now, you obviously know when you're in a car that it's the car that's moving and not everything around you. Your brain can process that. But imagine more what it's like when you're driving at night, when everything's dark. It's hard to know exactly how fast you're going because the only thing you really have to reference to are the lights of other vehicles. So kind of go with that idea. You can't really tell because you can't really see. Go with a very small frame of reference. So imagine you're in the car, okay, and you only have like a tube to look through, and you see this tree passing by, all right? How fast is that tree moving, assuming you're sitting still? So, what's the velocity of that tree? Well, it's going to be the tree, you're moving this way, the tree's sitting there, but it's going to look like you're sitting here and the tree's moving that way. So the tree, relative to the car, would be moving south. And it's going to be going at that 50 kilometers per hour that the car is moving. You're in the car and you have a sunroof. Okay? So the sunroof right here, you can see out the sunroof and you can see the helicopter. Okay? If you can just see that, clear sky, no clouds, nothing to orient yourself about how fast you're going, all you can do is see up and all you see is the helicopter and blue sky, how fast does it look like the helicopter is going? Well, as you move forward, the helicopter moves forward. So the whole time you're looking through that window, your sunroof, all you're going to see is the helicopter. It's going to appear as though it is not moving at all because they have the same velocity relative to the ground. So 0 is your velocity of the helicopter if your car is the reference point. So relative to the car, the helicopter is not moving. Now, if the helicopter is your reference point, okay, you're the pilot and you're looking through a little window down here below, and all you can see through that window, pretending you can't see the road or anything else, all you see is the tree. Okay? That tree appears to be moving what direction? Helicopter's moving this direction. The tree appears to be moving the opposite direction. Appears to be moving south with the velocity of 50 kilometers per hour. Okay? The car, however, when you're looking through that little tiny window and just seeing the car appears to not be moving because it's actually moving at the same velocity. So that would be a 0 kilometers per hour. Okay, velocity of 0. Okay, new scenario. We have a speedboat. Okay, the speedometer on the speedboat reads 20 meters per second. The speedboat is going north. The river's current is 5 meters per second, but going south. So you're going upstream. If you've ever tried to go upstream, you need to have a power boat to do it because otherwise you just don't seem to get anywhere. So pretending that this is what's going on, if the tree beside the river is a reference point, so you're standing next to the river watching this happen, watching this movement occur, what does the velocity of the river appear to be? This is where it kind of gets confusing because you're like, well, the river's current is relative to the ground. Since the tree is stuck to the ground, the velocity of the river is the 5 meters per second south. Okay? Now, the velocity of the boat. Because that 5 meters per second, okay, that's north, but the river is flowing 5 meters per second the opposite direction, that actually causes the boat to appear slower than the speedometer says it's going. So relative to the shore, it's only going 15 meters per second. Okay? But it is still going to the north, 15 meters per second north. If the river is the reference point, if you are floating in the river, so ever sat in an inner tube and floated down the river, okay, you go with the current, okay? What does the velocity of the boat appear to be? So if you're flowing with the river is what the boat is moving on. The boat is going to appear to be going the 20 meters per second north. Okay? Because that is what the boat is on, the river. Now, if you're floating on the river and you see a tree beside the river, and all you see is the tree, what is that tree's motion going to be? So you're moving this, so the river is flowing this direction. You are slowly floating this direction. And the tree's right here, and you're flowing this direction. It appears that the tree is moving towards you at 5 meters per second. So the tree is moving towards you. It appears as though the tree is moving north. Okay? Now, if the boat is reference point, if you are driving on the boat, you're driving on the boat, and all you do is look through maybe you look through your image on your cell phone, okay, using the camera on your cell phone. You can block everything out. How fast does the river appear to be going? The boat is on the river, so the velocity of the boat is that 20 meters per second, because that is what the boat is traveling on, so that's what its speedometer is reading. Now the river will appear to be going the opposite direction that the boat is actually moving, so it's going to be 20 meters per second south. The velocity of the tree beside the river is a little interesting because you have the boat that's moving 20, but the river that's slowing it down by 5, so the tree itself on the side of the river appears to be moving 15 meters per second. And so you're in the boat. If you're in the boat and you're moving this direction, it appears as though the tree is moving to the south. The back side of the worksheet you were supposed to do on your own or with a partner or in a small group in class. Now you get to check your answers. Here we have the train, whose speedometer reads 55 kilometers per hour. We know that it's moving north. We have a motorcycle on top of the train. The speedometer on the motorcycle says 15 kilometers per hour. And then we have a helicopter who's obviously going south, whose speedometer reads 25 kilometers per hour. Now you get to calculate the relative velocities of all the objects. Oh, and we've got a tree on the ground beside the train. If the train was your reference point, if you are a passenger in the train, all right, and you see the tree pass by, of course, pretend that you don't see anything else. You can't orient yourself and realize that you're what's actually moving. If you pretend that you're not moving, if you pretend you're holding perfectly still, how fast is that train moving and the tree moving and in what direction? So if you're right here, watching the tree, the tree appears as though it's moving this direction. The tree appears to be moving south with a velocity of the train, 55 kilometers per hour south. Now the motorcycle above. if there was a skylight here and you could see the motorcycle pass over the top, how fast does it look like the motorcycle's going? Well, the motorcycle isn't on the ground, it's on the train. The movement of those wheels on the top of the train is what the speedometer of the motorcycle is detecting. So the velocity of the motorcycle as it passes over the top of you is what the speedometer says on the motorcycle. So 15 kilometers per hour, and it is definitely going north. Now the helicopter. The helicopter is going the opposite direction. This is the same thing as you going one direction and an oncoming car is going the other direction. It appears to be going super, super, super fast. You have to add the velocities. You add the velocity of the train and the velocity of the helicopter. So the 55 of the train plus the 25 of the helicopter, that will give you 80 kilometers per hour, and the helicopter's moving definitely south relative to you. Okay? Next, the motorcycle. If the motorcycle is your frame of reference, how fast is the train moving below you? Well, the train, because that's what the wheels are actually on, that's where you get the 15 kilometers per hour. 15 kilometers per hour of the train below it. So the train appears to be moving the opposite direction because you're going forward. The train appears to be moving underneath you. So the train is moving south relative to the motorcycle. The velocity of the passing tree. Okay? Now the tree's on the side of the road. The train's already moving. The motorcycle is on the train. As that train is moving, that tree appears to be going by, so we know it's going south, but you have to add the velocity of the train and the velocity of the motorcycle because you have one on top of the other. As the train's going, the motorcycle's going even faster, so you have to add both of those velocities together to get what that velocity of the tree is going to be. So the 55 plus the 15 of the motorcycle, that gets you 70 kilometers per hour south. So the tree appears to be moving 70 kilometers per hour south relative to that motorcycle. The velocity of the helicopter relative to the motorcycle is extremely fast. You have the velocity of the train plus the velocity of the motorcycle because they're both going the same direction, and you're adding them onto the other, and then the helicopter is going the opposite direction, so you have to add up all three of those velocities to figure out that extreme velocity that appears that those two are with which those two are moving towards each other. So the 55 of the train plus the 15 of the motorcycle plus the 25 of the helicopter, you add that all together and you get 95 kilometers per hour. And that helicopter, if you're the motorcycle, that helicopter is definitely moving south. If the helicopter is your reference point, if you were the pilot in the helicopter, and you were looking through a little tiny window down here, okay, how does it appear things are moving? The velocity of the tree. Well, the tree is pretty much stuck to the ground. The speedometer relative to the helicopter, it's a direct relationship. So the tree appears to be moving 25 kilometers per hour, which is the speedometer velocity of the speedometer of the helicopter. And the tree appears to be moving. If the helicopter is moving this way, the tree appears to be moving that way. So the tree appears to be moving north. Okay? The velocity of the train. So this is, again, we've got two oncoming moving objects. The velocity of the train plus the velocity of the helicopter to get the relative appearance of the velocity of the helicopter. So you have to do the 55 of the train plus the 25 of the helicopter. Add those together and you get 80 kilometers per hour north. The velocity of the motorcycle relative to the helicopter. So that helicopter and that motorcycle, we have the train moving one direction. The the motorcycle moving as well, the same direction. We have to add those velocities because one's on top of the other. And then the velocity of the helicopter as well. You have to add them all together. So the train, the motorcycle, and the helicopter all added together, we've done that before, 95 kilometers per hour. But what direction is the motorcycle moving according to the helicopter? It's moving north. Okay? If the tree is your reference point, if you're sitting here next to the tree watching the whole scene happening, the train appears to be moving its 55 kilometers per hour going north. The motorcycle, if you were to nail it with a speed gun, you know, if you're a cop and you had a speed gun and you were to measure the speed of the motorcycle, it would be the 55 of the train plus the 15 of the motorcycle, which gives you the 70 kilometers per hour. And it appears to be going north. Motorcycle will be going north. The helicopter is just the velocity of the helicopter, the 25 kilometers per hour south. So there's your worksheet. You can check your answers.